Hello guys, this is CodeNCode and this is sixth lecture of basic algorithm series. In this lecture we are going to see how we can perform range updates in constant time complexity. And of course, as explained in the second episode of this week in competitive programming, uh, there is a specific condition under which this works. So the question is this: we are given an array of integers, we are having n integers and we are having q queries of two types. So first query is of form L, R and X, where you have to add element X, value X to all of the elements in the range L to R inclusive. So basically adding an element X into all of the elements in range L to R. Now type 2 query is you will be given an index and you have to print the value of that index. Now this problem seems familiar and seems easy because we have already studied segment tree. So and we have seen point update, range update, and this is a range update, and this seems like a standard problem for lazy propagation. And of course, one of the possible solution is to use lazy propagation to solve the first type of query. So we can perform range update in log n time using lazy propagation. So type 1 query can be handled in log n time, and second type of query can also be answered in log n time using the segment tree, of course. Now the question is, and the problem changes, the approach changes when we ask a simple question. And the complexity of this algorithm depends upon the answer of this question. The question is, does anything changes if I say that all type 1 queries appear before type 2 queries? So does anything changes if all of the type 1 queries appear before type 2 queries, or all of the updates occur before processing of certain indices? Well, if the answer is no, then the best we can do is this: type 1 query takes log n time and type 2 query takes log n time. But if the answer of this question is yes, then we can perform the updates in constant time, that is big O 1 time. So of course the condition that I was talking about, which I have also mentioned in the second episode of this week in competitive programming. And if one more thing, if you haven't watched that video, you can go and watch that video, because in that video we have decided that what we are going to study in this week, and this is the first lecture after that video. So and also I've mentioned that I'll be trying to cover at least 9 lectures in this week, as we have covered 8 lectures in previous week. So I'll be trying to cover at least 9 lectures in this week. So if the answer of this question is yes, if all of the updates are before the access of certain indices, or basically of the all of the type 1 queries are before type 2 queries, then we can apply the algorithm that I'm going to teach you. The updates you can perform in constant time. So to perform the updates in constant time, of course we need an extra array of the same size as the input array. So this is the input array. Say the input is 5136428119, and this is the update array, the extra array that we will be needing to perform the updates in constant time. And of course you need to initialize all of the elements in the update array with 0. Now suppose there is a query 355, that means from in the range 3 to 5 add value 5 to all of the elements, right? So how we are going to perform this operation? Well, to perform this operation, this update operation, what you can do is go to index L, add 5 to it, the value X, add 5 to it, go to index X, R plus 1, which is 5, so 5 plus 1 6, so we are at position 6, and decrement it by 5. So add X and decrement X. So what we are doing here, see this: for all of the updates of form L, R, X, go to index L, add X, go to index R plus 1, subtract X. This is how you perform update, and now this is done, the update is done. Now you may ask, okay, but nothing has changed here in the original array, and how we are going to print the index? Suppose the final query comes out to be index 6, I mean 4, index 4, so the value should have been 11. So how we are going to do that? How we are going to update the original array? So don't worry, of course, since I have to since all of the updates are before all of the type 2 queries, so before we process type 2 query, we have to pre-process this whole array, and then we have to change them into the final values. And how we are going to do that, let me show you in a moment, after I take one more update. So this is the second update, 5 7 2. That means from position 5 to 7 add 2. So 5 to 7, like here to here, add it 2. So what you are going to do, go to position 5, add 2, go to position 8, subtract 2, right? So now we have performed second update as well. Suppose these were the only updates, even though in the original problem there can be as large as 10^6 number of updates, or 10^5, 500,000 updates. So for now, just to explain you, I have taken these two updates. So we have performed the first update, we have performed the second update. Now suppose these two were the only updates, so how we are going to change the original array? Let me show you. So now we are going to change the original array so that each query of type 2 we can answer in constant time. Now these are the two updates that we had performed, so I've just put them here so that we can use them as reference. So to change the original array into the final array, the array which what it would look like after performing all of the updates, to do that we have to process this update array from left to right completely. So count, we need a count variable initialized with 0. So now we'll be processing this update array from left to right. These are, you can consider these as the pending updates. So now we'll be taking pending updates one by one and changing the value here in the original array. Now at index 1 we are having value 0, so add value 0 to count. Nothing would change, of course, so count is 0. And after adding the value, add count to first index I. So add 0 to 5, so it would be 5. Now I is equals to 2, so take this value, add into count, so count is 0. Add count to I is currently 2, so add count to this value. Of course nothing would change because count is 0, so this would remain unchanged. Now I is equals to 3 and the value here was 5, so we added 5 to count, so now count is 5. Now go to position 3 and add count to here. Now this value would become 8. So you see, index 3 at index 3 we had to add 5, and now we have added 5 here. Now go to next index, add 0 to count, count is 5. Now add count to original array at current index is 4, so add 5 at index 4, the value becomes 11. Now see, at index 3 and 4 and 5 all needed to be incremented by 5, so index 3 and 4 have been incremented by 5. Now let's go for fifth index. The value here is 2, so count becomes 7. So now what would happen? Of course this would be incremented by 7. And why is that so? See here, now index 5 is being incremented by 5 in first update, and index 5 is being incremented by 2 in the second update. So index 5 of course should be incremented by 7, and as you can see the value of count here is 7. So now add 7 to index 5 and the value becomes 11. So you can see whatever are the pending updates, count take care of everything. Now the index becomes 6. Now the value 6 should not be incremented by 5, and count contains the value 5. So what we are going to do, we are going to nullify the effect of 5, because we are going out of the range, and when you go out of the range this value should be nullified. Currently we are having the value 5 inside the count, so we must nullify it. And how you are going to nullify it? Simply remove it. And how we remove it? Of course by adding the negative of it. And that is why when you add at index L, you add the value x, and at index R plus 1, which goes outside the bound of the update, you add negative of it, so that you can remove the remove or nullify the effect of the current update. So that is why when you go to next index, which goes the out of bound of first update, you add -5 and the count becomes 2. Basically, since we are going outside the bound of this, the value of 5 is nullified, so that this is no longer present in count. So count becomes 2. So 2 would be added to current index, so it would become 4, and it is being added because of this update. Now we move on to this index, add 0 to count, and then count to original array, it would become 10. Now we move on to here, we add -2, the count becomes 0. Why we add -2? Because we are going out of bound of this update, and since we are going out of bound of this update, this should be nullified, and that is why we have added add index r plus 1 -2, and when you add this into count, this would become 0, of course, and now nothing would be added here. We would move on to here, nothing would be added here. Basically, these three won't change, and that is how we perform updates. Now see, what is the time complexity? Suppose the total number of type 1 query were n, so the overall time complexity would be big O of n after this, even after performing this. So, and if you do that using segment tree, the complexity would be n log n. There are n updates, and array size is also n, so the overall time complexity of type 1 query would be n log n if you use segment tree. But here, the overall time complexity of all type 1 query, if there are n type 1 query, would be only big O of n, not n log n, only n. So that is the difference between these two approaches. Now second, type 2 query would take log n time, but here type 2 query would take only constant time, because now if someone asks you what is the value at index this, what is this, 7 I guess, yes, at index 7, you can simply print, you can go to original array and print this. How much time it is taking? Constant time. While in the segment tree, it would require log n time. So this is the difference between these two approaches, and this approach can be used only if and only if type 1 queries appear before type 2 queries, or basically all updates occur before accessing the indices. So this was all about this lecture. If you have any doubt or query, of course you can ask that on the article that I've created on the discuss.codechef.com. The link of that article I'll be putting in the description of this video. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.